Hi, let's have a look at this question here in paper 1, time zone 2, May 2022 for physics high level, number 30. It says in two different experiments, white light is passed through a single slit and then is either refracted through a prism or diffracted with a diffraction grating. Now, the prism produces a band of colors which we expect the prism will split the white color into its constituents of the visible light from M to N, while the diffraction grating produces a first order spectrum P to Q. Now, the question asks, what are the colors observed at M and P? Okay, so in order to solve this question, we need first to review our knowledge about both diffraction and refraction. So let's start with diffraction. So diffraction grating is a device by definition that is mainly used to separate light into its constituent wavelength via angular dispersion, or basically diffraction. So this diffraction grating is an application of multiple slit diffraction, and then it acts as a prism. So diffraction grating also, will act as a prism. So when you see this image, right, so the white light will pass, okay, first maybe by single slit, and then from the single slit into the diffraction grating, which has many slits, multiple slits. So you see here the color, you see the visible light from red from red to violet. Okay, so if I remember only this schematic or this image about the diffraction grating, I can clearly see the red light here is on the edge, on the extreme, with the biggest angle of diffraction, right? So that could be enough to say that P here has to be red, because also when you look at the options here, we have only two colors, red and violet, which actually the extremes of the visible light, right? So that's one quick way. Another more way using formula, you look at the formula used for diffraction grating. You say n times lambda equal d sine theta, where n is the order of spectrum or the order of diffraction, right? Lambda is the wavelength of any certain color here, of all of these colors. Of course, the wavelength range of visible light between 400 to 750. So 700, 750, about 750, 700, this is the wavelength of red light, while 400, which is the minimum wavelength in the visible light spectrum, is going to be for violet. Okay, so and then on the other side we have D, which is the slits separation or the distance between two slits, and sine theta, which is the angle of diffraction. Basically it's the angle between the center, let's say the center or the central line here, or the central axis, to the whatever light diffracted. Okay, so when you, from this formula here, we can actually say that lambda is directly proportional to theta or to sine theta, right? So the bigger the angle, the bigger the lambda. The smaller the angle, the smaller the lambda. So now we can see here, red actually has the biggest angle of diffraction from the center, right? Which means red will have the biggest wavelength, right? Or confirming that red having the biggest wavelength, and the violet will have the smallest angle of diffraction, which confirm that yes, violet has about 400 nanometer, which is much smaller than, or smaller compared to the red light. So these two approaches now confirm that P has to be red and Q has to be violet. So now when you look at this question here, P has to be red, so we are looking at 50-50. So I can actually exclude B and also exclude D. So it's basically, 50-50. Now, the second phenomena that we would like to also refresh our memory about, in order to solve, okay, now I have prism. Now the main phenomena here is refraction, and I have two refracted rays, right? So now let's quickly review refraction. So refraction, as you know, when is actually the change in the direction of propagation of a wave when it passes from one medium to another. And the change in propagation or change in the direction is due to the change in speed. So the speed of the wave in the second medium, right, is different than the speed of the first medium, and this is due to the difference in optical density, right, of the medium. Okay, so this is just a definition of refraction. Now, Snell's law is the main law governing the refraction, right? So you say N1 over N2, which is the refractive index of medium 1 over the refractive index of medium 2 is equal to sine theta 2 over sine theta 1 equals C2 over C1. Now, theta 2 is the angle of refraction, which is between the normal and the refracted ray. Now, theta 1 is the angle of incidence. Now, when you look here, see theta 2 here in this example is smaller than theta 1, right? Which means the refracted ray is being refracted closer to the normal, right? Now, the other version, or the second version of Snell's law, that's N1 over N2 also equal to C2 over C1, where C2 is the speed of light, or this. Okay, now we talk about light. Okay, let's say light. So the speed of light in the second medium versus the speed of light in the first medium, right? Now, so when you look at this, okay, and seeing that the theta 2 here is less than theta 1, so C2 also has to be less than C1. Okay, so that means what? That means when the light slows down, okay, it means it will refract closer to the normal, according to this formula here, according to Snell's law. Make sense? So now when you look back at the question, we have two different rays, but one of them actually is refracted closer to the normal compared to the first one. Like N here is closer to the normal compared to M, right? So I can say now that actually whatever that light is of N, so I can say C of N, or the speed of N, has to be less than the speed of M. Okay? Now, the national anthem of waves, traveling waves, the speed is equal to F times lambda, where F is the frequency and lambda is the wavelength, right? Now, as a matter of fact, also in refraction, the frequency doesn't change. The frequency doesn't change. So that means if the speed is changing, or let's say decreased in the second medium, okay, and the frequency is the same, it means also lambda has to go down, has to decrease as well. Okay, so from these formulas, or from these facts about refraction, we can also say that lambda n has to be smaller than lambda m, or lambda is the wavelength, right? Which means what? Which means m has to be red and n has to be violet, because wavelength of red is about 750 nanometer, while the lambda, or the wavelength of violet, is about 400 nanometers. So that means the answer has to be A. Okay, so that was a quick review about refraction and diffraction. This is very good question in paper 1 question, high level, linking between linking topic 4 and topic 9. So please feel free to leave any comments, any questions. If you have a certain question in past papers, please tell me, write in the comments, and I will try my best to solve it for you or discuss it with you. Okay, thanks for listening and have a wonderful day.